Okay, this is Unit 6, Lesson 1, introduction. And first of all, the first part of the course, we work with whole numbers. And can anybody tell me basically what a whole number is?
It's on the right side.
Yeah, it's counting numbers, right? There's counting numbers like 1, 2, 3, 4, 5. Whole numbers, the only difference between a counting number and a whole number is that a whole number has 0 in it, whereas counting numbers don't. So if we were to look at a number line, and that continues on indefinitely. Whereas integers, not only have 0 and counting numbers, but they also have the opposite, what we call the opposites, negative numbers. So we can say that integers are positive and negative whole numbers in a way. Now, when we say, if we were to come up with a solution, let's say, as x equals a -3, okay? Well, sometimes what happens is people will, they will come up with a solution, but they forget the negative. And it looks like one little tiny negative, right? But the problem here is that -3 and +3 are two totally different numbers. So that one little negative really makes a big difference. Makes that a whole different number. So you have to really watch the negatives. Okay, and it's the negatives that tend to give people some trouble. Okay. All right. So if we wanted to graph, when we say graph, x equals -3, we want you to put a dot. We want you to draw a number line and put a dot on that number. Okay, wherever that may be. And so for each one, normally there's 2 dots here, but so for each graph, you want to draw, for each number, you want to draw a separate number line. Okay? All right. On problems on page 182, problems 9 through 14. We have which number is 5 units to the right of -3. Okay, here's your number line. Here's -3 to -1, 1, 2, 3. Now before we go any further, 0 is like the center point for our number line. From 0 we go 1, 2, 3 to the right. From 0 we go -1, -2, -3. A mistake that students make is that they're used to writing numbers from left to right, from 1, 2, 3, and so on. But what they'll do is they'll put -1, -2, -3. No, you don't do that. You're looking from 0, you're going more negative. And the more negative you go, the smaller the number is. Okay? Like if you had $1 in your wallet or in your purse, and you spend that $1, now you have 0. Now let's say that you wanted to borrow $1 from you're $1 in the hole. If you want to borrow $2, now you're $2 in the hole. So the more negative you go, the more in the hole, or the more, the lesser number you have. So you want to say that as we're going from -3, and we're going 5 units, 1, 2, 3, 4, 5. Okay, so actually I don't want to dot at -3. I do want to dot at 2. So which number is 5 units to the right of -3? Right, we're going to say 2, or you can put +2, but you don't have to put +2. You can just put 2, because without the sign it's implied that it's positive. Alright? So when we're looking at addition or subtraction, we can say that 5, we're used to seeing 5 minus 3 is 2. But what we're not used to seeing is -3 plus 5 is also 2. So we're looking at 3 units in the hole. Let's say you're 3 units, $3 in the red or in the negative. And let's say you got $5. So now you paid back your friends and relatives, and now you've got $2 left over. Okay, so with integers, when you have opposite signs, no matter which one is larger or smaller, your answer is going to be that sign of that. You're going to subtract, and the answer is going to be the sign of that, whatever the difference is, whatever your larger number is. Okay, so let's say in this next problem,